Hello everyone, welcome to this video where we're going to be looking at how we can use S-FRAME to generate wind load cases according to ASCE 72022 provisions. So I've got two different models that we'll work through today. The first one being a 10-story structure that is relatively square in its plan. We've got a core wall at its heart and also some external bracing, as you can see. All my floors are modeled with rigid diaphragms, and you'll notice here if I just go to the floor definitions tool that I have floor definitions starting at 1 and working their way up sequentially from 1 to 10 with no gaps as I go up. And that's an important, aspect of this model. We need to know where one floor starts and the other begins. And if we build this with the multi-story builder, that will be taken care of for us automatically, but we may have to assign this if it weren't generated with that type of method in mind. So currently in this model, if we just look at the loads window, we don't actually have any loads defined. And our main goal here, let me just unshrink these elements, is actually to define wind loads. So we're not really concerned about all the other types of loads in this model. So I'm going to go to the settings menu here, and I'll go to preferences. And under the preferences dialog here, under the design codes tab, we can select our building code. I'm going to grab ASCE 72022. You'll notice there are two tabs. There is the ASCE 722 E for earthquake, and then the next tab over is W for wind. And within this wind tab, we have the various wind coefficients that we can enter, like the wind speed, the exposure type, and so on, that is relevant to our specific site. We also have eccentricities, which we can specify here, and wind pressure coefficients. You'll notice here for the wind pressure coefficients, the CP value can actually be user specified. We can set it to be whatever we want it to be, or it can be program determined as well. So S-FRAME will automatically determine that based off the aspect ratio of our building. Now for this particular building, it's pretty straightforward because the aspect ratio of the floors isn't changing as we go up in height. However, as you'll see in the next example, it actually does change as we go up. So I'll explain more about that later on. So I'm just going to click the OK button to accept all these parameters. So I'll click OK. And maybe I'll just change my view of this model as well. Turn down the turn up the transparency level rather, so I can see a little bit more clearly what's happening. And under the loads window, I have this new option here under the edit menu. Well, we've always had the option to generate open structure wind loads, which might be great if we're dealing with like a lattice structure or something more industrial in its nature that isn't necessarily enclosed. But that's not the case here. I'm actually dealing with an enclosed structure, so I'm going to use this option. And you'll see that we have the option to generate wind load cases. We can generate just the lateral loads. We can also generate the torsional and lateral loads combined, or we can generate all of them. So lateral loads plus the 8 torsional and lateral loads combined together. And we also have the option to update existing load cases if they exist in our model. I'm going to also set here, let's set up a base load case name of wind. I'll click OK. And you'll notice here, if we don't have a rigid diaphragm mass joint, S-FRAME will automatically create one. And it's basically going to be our wind face joint that's going to be used to apply those loads to it. And it's up to us to make sure that that connects to the relevant elements. In this scenario, all of my wind face joints are going to be located on my rigid diaphragm plane, so it won't really make a big difference in terms of what I would have to connect. But if we were meshing this, it might be a little bit more important for us to review that. I'm going to click the OK button now. And let me just look at the side view of my structure. You'll notice right away, first of all, that we have about a dozen different load cases generated. So I have wind 1x, wind 1y, wind 2 x plus the eccentricity in x minus the eccentricity in x, wind 2y plus the eccentricity in y minus eccentricity in y, and so on. So that equals 12 in total. And if I just look at one of my side views here, and I'm going to display my joint loads, I can see all the different magnitudes that are being used. Now it might be easier for me to actually use the joint load tool here, and I'll toggle this off and I'll say, let's just look at X force, and I can see the magnitude of the X forces. I'll turn off the rendering so it's a little bit more clear. for each one of these floors that's been calculated for me. I can also look at the Y direction or the Z moment direction as well, which is determined based off those eccentricities. And we're talking a little bit of rigid diaphragms. So again, if we have a rigid diaphragm, it's going to apply those loads to the master joint in our diaphragm. As you can see, that's where it's landing here. And if we didn't have rigid diaphragms, the program is going to calculate where that wind face joint should be, and it creates it in the plane of the diaphragm or the floor system. Now for this example, I chose some geometry that was nice and orthogonal. It hasn't really changed as we've gone up the height of the structure. However, I have another example here, which I'll just review. As you can see, it basically steps back in terms of the elevation as we go up. Maybe a side view would be a little bit more telling of what's happening here. So again, we have rigid diaphragms. We also have a core and columns, and basically we want to do the same thing that we did for the last model, but using this approach. So the workflow is going to be identical. We go to Settings, Preferences, make sure that all the information is set up the way we need it to be for the wind. So I'm going to stick with the defaults again. The one thing I do want to draw our attention to is the wind pressure coefficient, CP. I'm selecting the program defined option, and what's going to happen is basically if the L over B values, the aspect ratio of our floors, varies along the height of our structure, S-FRAME is going to use the smallest ratio for all floors, which will lead to the highest wind pressure. So I'll click OK. And let me go to the loads window here. I had already been playing around with this, so I had to delete those joints earlier, or those joint loads. But I'm going to regenerate them, generate and close structure wind loads. And once again, I'll do it for all my load cases. Let's call this wind. And if I look at the side view, we can see here that it is indeed generating these loads for me. And the location of these wind face joints rather, is varying on each level because the plan is varying as well. But it's important to note that it's using the smallest L over B ratio of all the floors to calculate the pressures on the floors there. So just something to keep in mind if you do have a multi-story structure that does have a varying floor plan like this one. If you'd like more information about the implementation of the wind load generator in S-FRAME, you can go to the Help menu under Contents. You'll find plenty of more information. Actually, you can see here, it's actually pointing us to the latest, but we can search for example ASCE 722. And you'll notice here that we have information about the seismic force generators, the enclosed wind structures, and more information about how it determines all these values.